Hello everyone, my name is Titano and today we are going to solve the problem of the week. So what is the problem of the week that we have today? So we have given A, given alpha and beta are roots of the equation 2x squared plus 3x minus 5 equals to 0. Evaluate alpha cube plus beta cube. Okay, so how are we going to solve this problem? So first, let's take a look at the equation itself. This is what we call a quadratic equation because the degree of the polynomial is 2. Because the highest exponent that we have here is 2. Okay, now let us consider what the question asking. So they say alpha and beta are the roots of the equation. So since we know that alpha and beta are the roots of the equation, we can use the Vieta's relation for this question, for this equation, where if we consider the equation in its root form, so x minus alpha times x minus beta equals to 0, when we expand them, we get x squared minus alpha plus beta x plus alpha beta equals to 0. So this is where the Vieta's relation comes in. It says that if the quadratic equation is in this form, in the root form, when you expand it, we can see that the coefficient of x to the power of 1 is the sum of the roots of the roots of the equation, whereas the constant of the equation is the product of roots, which what we call as POR, SOR and POR. This is the simple one. So from here, we'll notice that our equation is not equal. The leading coefficient of the equation is not 1. How do you want to solve it? Don't worry, we can divide the whole equation by 2 and the roots will stay the same. So let us divide it by 2 and we get x squared plus 3 over 2x minus 5 over 2 equals to 0. So from here, what is this SOR and POR? So let us compare these two. So we notice that the POR, the product of roots, is negative 5 over 2. Whereas the SOR is what? The SOR is a negative 3 over 2 because alpha plus beta and then there's a negative in front. But here we have the positive. So alpha and beta must be negative so that the SOR becomes, so that the coefficient of the x to the power of 1 is 3 over 2, positive. Okay, so we already have our SOR and our POR. Now let us take a look at the third one, the ending. Evaluate alpha cube plus beta cube. Alpha cube plus beta cube. How are we going to solve this problem? Because this is cube. The question just goes until quadratic. The degree is 2, but the question asks for 3. Don't worry. From this part, we can factorize this. Okay. We can factorize alpha cube plus beta cube. Okay, before that, let us just put alpha beta on the right hand side here. Alpha plus beta. Okay. So, from here, what do? We can factorize alpha cube plus beta cube into the following equation. Alpha plus beta times, okay, alpha squared minus alpha beta plus beta squared. So we have this. Now let us rearrange a bit. So we have alpha plus beta, and we have this one, alpha squared So we notice that there's a minus here. So let us consider minus 2 alpha, 2 alpha beta. So minus 2 alpha beta plus beta squared plus alpha beta. What is this? What's this? Why you want to add? Why you want to minus another 2 alpha beta? You are making it a bit more complicated. Actually, no. We are not making it more complicated. We are making it more simple. Why? Because actually, let us just change it to, okay, excuse me. Instead of putting it 2 alpha beta, let us change it to plus 2 alpha beta. Because why we want to change it to plus 2 alpha beta instead of minus? Because we are targeting to get alpha plus beta to the square. This is what we want to aim for. But since this is minus, so what do we want to do? We will have to change it to plus 2 alpha beta first, and then look what we can might deduct from the one that we want, which is alpha plus beta squared, so that we can get the original one, which is the alpha squared minus alpha beta plus beta squared. So we notice that we just have to put minus 3 alpha beta on the right, so that everything is balanced as it should be. Okay, so we have this. So now we can simplify this, becomes alpha plus beta. This becomes alpha plus beta squared minus 3 alpha beta. And let's just make it into a rectangular bracket. Okay, so we get alpha plus beta squared minus 3 alpha beta. So from here we have our sum of roots and product of roots. This is why I want to put I want to make it into alpha plus beta squared, because I want to easily put inside our values here. So we have our sum of roots is negative 3 over 2. So we put negative 3 over 2 here, not 3 over a, my bad. Times with negative 3 over 2 squared minus, in bracket 3 times what? Alpha beta is times negative 5 over 2. Like this. Actually, I should put it like this. Like this. Okay. So from here we make it stay the same. So negative 3 over 2 times. So negative 3 over 2 squared is 9 over 4. Minus, this is 15. Actually plus 15 over 2. Okay. So let us equate the denominator. So we have 15 over 2 becomes 30 over 4. And we have 30 plus 9 equals to 39 over 4. And from here, we times again, and we get, okay, 3 times 39 becomes, let me see, 177 over 4. And don't forget the negative in front. So this is the solution. Oh yeah, I forgot. My bad. This is the answer for our equation, our question, which is negative 117 over 8. So do you get the answer? If you like this video, please leave a comment on how you answer these questions. Maybe you can give another solution for this question, right? And then don't forget to subscribe and ring the notification bell so you can get the weekly problem of the week from me. Okay, with that, I'll see you guys in the next video. Chatano out. Bye bye.